So it says cos theta equals negative 3 over 5. That is that's not on our unit circle, right? But when we see cos or sine or tan equal something, that's giving you two sides to a triangle, right? Always. I know that cos of theta equals x over r. That means they gave me an x value of negative 3 and an r value of 5. I can sketch this now. There's two different triangles I could build that would have an x value of negative 3 and an r value of 5. I could build one like this. 5, negative 3, and y. Or I could build one like this. 5, negative 3, and y. And I don't know which triangle is correct. Both are valid, just based off of cos equals negative 3 over 5. Both of those are valid. Is everybody okay with that? Like putting the two sides? R is the value coming out of the origin, right? Negative 3 is to the left. Okay, so how do I know which triangle is right? Because one of them is right and one of them is wrong. Yeah.
Wouldn't it be the second one because of the tan theta is larger than 0?
Yeah. This right here. Tan theta is bigger than 0. They're telling you that tan is positive. That's y divided by x is positive. That's what that's saying. Tan is y over x. Greater than 0 means positive. There's two places where tan is positive. It's positive in quadrant 1 or 3. In quadrant 1, y divided by x, positive divided by positive. That'll make a positive number. Quadrant 3, negative divided by a negative. That would make it a positive number. So I'm in quadrant 1 or 3, meaning that that red triangle is incorrect. I need to build that purple one. Perfect. Building the rest of that purple triangle. I need to find my y value. My y value is going to be done using Pythagorean theorem. 5 squared minus negative 3 squared is going to be 16. Square root of 16 is 4. This is negative 4 because I'm in quadrant 3. It went down. So now I have my triangle. It's 3, 4, 5. We've seen that a lot during this review, right? So we don't waste time on Pythagorean theorem every day. Is everyone good with just building the triangle and building it in the right quadrant? We haven't answered the question yet. We just built a triangle. All right. Now let's answer the question. They want to know what sine squared of theta minus cos squared of theta is. Well, sine is y over r squared. Right? Sine is y over r. They want that squared. Minus cos is x over r squared. Yep.
To get that negative 4, you did Pythagoras theorem?
Yeah.
Okay.
Yeah, I did. Yeah, I just did it really fast. Anytime you have a triangle of like a hypotenuse of 5 and one of the sides is 3, it'll always make 3, 4, 5. Yeah. But I did do Pythagorean theorem. A squared plus b squared equals c squared. Okay, putting this in. That means I have negative 4 over 5 squared minus negative 3 over 5 squared. Make sure you use brackets, right? Otherwise your negative is getting squared, won't do it properly. You should have got, if I do this by hand quickly, 16 over 25 minus 9 over 25. Throw that in your calculator, and you should get 7 over 25. I think I could do that as a decimal. I think it's 0.28, but you should definitely write as a fraction, like math frac that. Is it 0.28? Oh. Genius. Yeah, like you could, and it would be acceptable to do this because it terminates. If it doesn't terminate, you can't do that. So all of our irrational ones that we talked about, can't do that. Feeling okay? All right, let's look at number 14. If the value of cotangent A and the value of secant of A are both negative, then, and you have to decide where A is going to be. All right, the first one says 0 to pi over 2. That means quadrant 1. Zero to pi over 2, that's quadrant 1. Pi over 2 to pi, that's quadrant 2. This one's quadrant 3. This one's quadrant 4. Okay, so which quadrant are we in? Well, they told me that cotangent of A and secant of A is negative. Let's start with cotangent A is negative. Cotangent of A is the reciprocal of tangent, so that means x divided by y is negative. That means x and y are opposites. All right? If they were both positive, that wouldn't work. If they were both negative, that wouldn't work. So they must be opposites of each other. So that means we're in 2 or 4. We agree? Second piece of information they gave us. They said secant of A is negative. Well, secant is reciprocal of cos. Cos is x. They're saying 1 over x is negative. That means your x value must be negative. So that means you're in quadrant 2 or 3. If both those statements had to be true, that means you're in quadrant 2. Any questions on that? How I figured out something was negative or positive? Alright. Let's do some trig graphs. So there's 3 types of trig graphs that you're going to have to know. These are their mother functions, meaning that's like their standard function, just sine of x, cos of x, tan of x. Yeah, very basic. No transformations done to them, nothing. The 2 that you definitely need to focus your energy on are sine of x and cos of x. Tan of x does come up, it just sometimes it doesn't, right? Like it's not nearly as important. Cool. Things to remember about sine and cos. They're actually the same graphs, just translated slightly to the left or right, depending how you want to look at it. But both have a lot of similar traits. The highest either graph goes is 1. The lowest either graph goes is -1. So if you look at your basic sine graph, maximum is 1, minimum is -1. Same with your cos graph. Maximum is 1, -1 is your minimum. We're looking at my sine and cos graph. The period is the same. Period means how long it takes until the graph starts to repeat itself. You can see it's highlighted in red for you. So looking at the first one, if I started right here at the y-axis, it goes up, back down, and you can see at that point it just starts to repeat itself again. It starts to go up and down again. That distance is 2 pi. We call it the period. It's how long it takes to repeat, how long it takes to cycle. Cos is doing the exact same thing. So if you look at cos, the amount of time it takes until it does one full cycle is 2 pi. Starts at the top, goes to the bottom, goes back to the top. Yep, that took 2 pi. That makes sense. The reason it makes sense is because that's really graphing your unit circle, where x is your angle and y is either your y value or x value of your unit circle. So if you think about sine, this means y value. The y value on my unit circle is 0 at 0 degrees. As I start to go around my unit circle, I get to 90 degrees. I'm at the top of the unit circle. I'm at 1 now. I go down my unit circle. I hit my x-axis at pi. That means my y value is now 0. I go around my unit circle. I get to the bottom of the unit circle at 3 pi over 2. My y value of 3 pi over 2 is negative 1. And then I continue around my unit circle until I do one full rotation, 2 pi, and I'm back at 0. Same thing's happening here. Cos is x value on your unit circle. The x value on my unit circle starts at 1. I start to go around my unit circle. I hit the top of my unit circle. My x value is now 0. I continue to go around my unit circle. My x value is now negative 1. I come back around to the bottom of the unit circle. My x value is 0 again. And I do one full cycle of my unit circle. My x value is back to 1. This is really just a graphical representation of the unit circle. That's why it makes that pattern. That's why one cycle is 2 pi, because it's one spin around the circle. Tangent creates an entire mess. Right? It's like a whole new ball game. The reason why tangent makes a mess is because the cycle is shorter for tangent. Tangent is y over x. When you start at 0 on your unit circle, y over x is 0. As I get closer to the top of my unit circle, my y value is going to be getting much bigger, and my x value is getting really small. When you divide by a very small number, you get really, really large really quickly, right? Which is why it goes up so high. So for instance, if you had like 0.9 divided by 0.1, it's actually a big number because I'm dividing by such a small number. When I hit the top of my unit circle, though, I'm dividing by 0. It creates this asymptote. And then I start again, but now I have a positive divided by a negative. So I have a really big negative number until I go back up to the x-axis, and then I go back down to the y-axis, and I create that same cycle. So tangent actually has a period of pi, just because of where those asymptotes end up happening. You have to know these two. No doubt about it. You've got to know those mother functions. If you forget tan, miss tan, life happens. It might cost you one question. Maybe it won't cost you anything. If you don't know sine or cos, those mother functions, you're in a world of pain. You're for sure going to miss out on at least one or two questions. So make sure you know those. Yes?
From what you're telling us, is just know that sine starts at 0. Well, it starts at 1.
Yeah, just the mother functions, right? Sine starts at 0, then it goes up. Cos starts at 1, and then it goes down. If you ever forget a mother function, stress and anxiety does funny things in your brain, right? And it makes you forget things. So you're halfway through a diploma exam, and you're stressed out, and you're trying to remember where sine of x starts, and you're does it start at the top or in the middle? And you can't remember. Maybe it's a different mother function. Maybe I do not remember what my log function looks like. What could you do to help you out?
Just graph it.
Graph it. Graph in your calculator. Go to your calculator, graph sine of x. It'll make that exact pattern. Go to your calculator, graph log of x. It'll give you the mother function of log x. Right? Like, you, as much as memorizing it is nice and just knowing it, like, your calculator's got it for you, right? So, like, just graph it if you get desperate. And then you will remember. Cool. Let's talk about transforming these mother functions. So again, number 1, it says using the language of transformations. That means we need to write things properly. Describe how to obtain the graph of each function from the graph of y equals sine of theta or cos of theta, depending on the question that you're looking at. All of these transformations are doing different things. We're just going to go from left to right. Let's start with the 3. What type of transformation happens to the outside of your function and multiplies?
Vertical stretch.
Boom. We have a vertical stretch. You must write out the full sentence. Vertical stretch by a factor of 3. About the x-axis. Meaning that I'm stretching away from the x-axis, which is vertical, right? I'm going away from the x-axis, that's a vertical move. Next number I have is a 2. That 2 is inside my sine function. It's inside the brackets. That means it's doing something to my x values. What is the transformation that's happening?
Horizontal stretch.
It is a horizontal stretch. Perfect. Horizontal stretch. By a factor of 1/2. Right, remember our horizontal stretch is reciprocated. All of our horizontal things are opposite of what you think they are, so the stretch is a reciprocal. About the y-axis. Remember, if I'm changing my x values, I'm getting away from my y-axis. Right? I'm stretching like this, so I'm moving away from my y-axis. I wrote a little too big here. My next one. I have a pi over 3 there. I don't want to do that in blue. I already used blue. I'm going to do it in green. It's inside the brackets. That tells me it's a horizontal transformation. What transformation is that pi over 3? It is a horizontal translation. Okay, so meaning left to right. So horizontal translation. Pi over 3 units. And then you got to decide a direction. Horizontal means left or right. Are we wanting to move left or right?
Right.
We are moving to the right. Correct. Even though it looks like it's negative pi over 3, it's actually not negative pi over 3. That value is pi over 3. The subtraction comes from our transformation formula, right? Opposite of what it looks. And my last one, we have a plus 6. That would be a vertical translation. Six units up. Perfect. right, I'm going to let you try B. Before I let you try B, we can't write the transformations in the form that it's in. What's wrong with B? What's an issue that we're going to run into with those transformations or describing them?
You have to factor out the B value.
Yeah, you got to factor out that 2. So remember that nothing can be directly touching the x value. So I GCF at 2, and it becomes x plus 45. That is very much a trick that happens on diplomas. I've seen that many, many, many times, where people immediately jump into the question. They're like, oh yeah, stretch 1/2, 90 to the left. Which is not actually true. It's not 90, it's 45 that you're moving. So make sure you GCF the 2. There can never be something directly on the x when you're talking transformations. You must GCF it. Then you can talk transformations. There's 4 transformations there. I want you to try to write all 4 properly. I'll give you a minute here as I write the answer down as well. Yeah.
After around 45, would we say 45 units or 45 degrees?
Both would work. I would say 45 units still. Because if you're graphing it, it's moving to the left 45. Yeah, so units would still work. Alright, I got all 4 up there. You don't have much choice for wording. You kind of got to have the same as me. Things that might, like, I don't know. There's not much wiggle room there. Your sentence kind of has to look exactly like mine. You do have to use the word like factor. If you said, maybe if you didn't use the word by, you said with a factor or something like that, that'd probably be okay. But like, it's small window for error on these sentences. Okay, we've got 5 minutes, so we're going to do 2A, and then we'll be done. We're going to talk about some terminology that we see with trig graphs. Okay, so we're going to see things like amplitude, period, phase shift, stuff like that. Your standard one that's on your formula sheet is right. Oh, it's not on your formula sheet. Sorry, -2 life, they get it. Oh, no, you do. It's down here. So if you look in the very bottom right-hand corner, you will see they've written this. A sine B x minus C plus D. So they've written it as like a transformation. They've shown you all 4 letters. They use A, B, C, D when it comes to trig. Perfect. A, B, C, D all relate to different things, so I'm going to write those values and that stuff down. A is called your amplitude. The amplitude tells you the distance from the middle of your graph to the top of your graph, or middle of your graph to the bottom of your graph. That's what amplitude is distance from mid to max or min. It's the same distance. From the middle of your graph to the top, or middle of the graph to the bottom, is the same distance. So when I say the amplitude is 1, that means it's a distance of 1 to the top, also a distance of 1 to the bottom. Your B value is not your period, but it is related to your period. The B value equals 2 pi divided by your period. You could rearrange that formula to then calculate your period. The period is 2 pi divided by B. It's still a horizontal stretch, right? But in terms of sine, the B value, because it's stretching horizontally, is affecting how long your cycle takes. Your C value. When it comes to sine and cos, it's called a phase shift. That just means horizontal translation. Moving it left, moving it right. It doesn't tell us anything else. There's no other fancy thing about that. It's just how far left or right you went. And my D value is our midline. It cuts your graph perfectly in half. Sometimes your midline is also called the average. Haven't seen it a lot in Dash 1. But it is technically the average of your graph. There's an equal amount on top as there is on the bottom. It averages out to the middle. Perfect. After school today, when we do our tutorial, we will use that information to answer some trig questions. I will try my best to record after school as well. These look like they did record, just a little choppy.